Okay, now part 3. So now this one, we're still working on quadratics. This one is finding solutions of this quadratic. Now, this is already kind of broken down into this, I'd say the third step for solving by square roots. So if you have this situation, the next step would be to simply square both sides. So let's square both sides here. Or take the square root of both sides, not square both sides. And over here on the left, I get x minus 2. And on the right, the square root of 36 is 6, but I always need to remember, if I take the square root, especially when I'm finding solutions, that there could be two possibilities. Because the square root of 36 could be both negative 6 and positive 6. That's why we write plus and minus, because it could be either one. Alright, now I want to find out what x is equal to, so I'm going to add 2 to both sides. And x is going to be equal to 2 plus or minus 6. And let's just go ahead and find those two different solutions. So 2 plus 6 is 8, and then the other solution would be 2 minus 6, which is negative 4. So there's our two solutions. Okay, go to the right, number 29. Now I got to state the zeros. So again, you just got to figure out what numbers do I plug in here to make these 0. Well, for the first one, it would be 0 here. And then for here, it would be 9. So those are 0 and 9. And for this one, this is actually, let's expand this. And it could be, well, it's only 2. So x is equal to 2. There's only one solution. Now this one, for the first binomial, it would be negative 2, and for the second, it would be negative 4. Then this next one, as I solve from number 2, it doesn't matter whether I expand it or not, because there's only one number that can go in each of those binomials, whether I expand it or not, so this would be x equals negative 6. Okay, there's the solutions for those. Let's go down to number 25. Now, which number should be added to complete the square for each of the following? So remember, when we're completing the square, we're going to use this little formula. So again, use your flashcards if you don't remember this one. So you're just going to go through and use this formula to complete the square. So now, 12, so this first one, 12 divided by 2, is 6, and 6 squared is 36. Next one, 16 divided by 2, is 8, and 8 squared is 64. Next one, negative 20 divided by 2 is, and squared, is going to be negative 10, and that squared is 100. And then next one, negative 28 divided by 2 is going to be 14, and negative 14 squared, let's go to our calculator here, 14 squared, 196, that would be 196. Okay, that's all you have to do for that one. Okay, so now, go to the right to number 30. Find the zeros of x squared plus 10x plus 29 using the quadratic formula. So we're at these quadratic formula. Again, if you don't remember this one, use your flashcards. There's our formula. So all we have to do with the quadratic formula is, 1, remember it, and 2, just plug in the values once you have it. So now it's going to be negative times 10, our b value, 10, plus or minus the square root of b squared, which is 100, minus 4 times a, which is 1, times c, which is 29, and then all that over 2 times the a value, which is 1. Okay, let's go through and simplify it all. So we got negative 10 plus or minus the square root. Let's see, 4 times 29. It's going to be 4 times 29 116. Okay, so now we're going to have 100, minus, 116 all over 2. And then that simplifies to negative 10 plus or minus the square root of negative 116. I'm sorry, negative 16. Now, if you remember, when we have a square root of a negative number, that negative in front of the number just becomes I, or imaginary. So this becomes I times the square root of 16. So we take out the negative, it becomes I. Alright, so I'm doing this kind of one step at a time, see where it's all coming from. And then we could take the square root of 16. So now I have 10 plus or minus the square root, square root of 16 times I, which would be 8 times I over 2. So now we've got a complex number to deal with, or imaginary number. And if you remember, when you have a discriminant that's less than 0, you're going to have two imaginary numbers, and that's why we end up with I here. Because the discriminant is negative 16 up here in this step. So that's why we end up with I in our solution. So the first solution will be x equals negative 10 plus 8 over I plus 2. And remember, with a complex number, you need to separate it in two parts. So anytime you get a number with an I in it, we need to separate it. Okay, and split it down the middle. So now we get 10 over 2 plus 8 over 2, I. And let's simplify that again. So 10 over 2 is equal to negative 5 plus 8 over 2, which is 4. So there is our first solution. X equals negative 5 plus 4. And I know the next one will just be negative, will be minus 8i. So it'll be the same thing if we work it out. Negative 5 minus, oops, sorry, not 8, but minus 4i. Okay, and there's our two answers. Okay, let's go over here. Now we got to find the roots of each of these quadratic functions by factoring. So this first one we can factor just by doing reverse FOIL. And I'll do the magic X so you guys can see. So I'm going to have to figure out a number that can add to 2 but multiplies to negative 8. Well, I know 4 and 2 probably will get us there, but one of those has to be negative. It's positive 2, so the smaller number will have to be negative. Okay, so now we have x minus 2, x plus 4, and the last thing is finding the roots by finding the numbers that make these x's 0. And the first one would be positive 2, and the second one would be negative 4. Okay. The second one, we're going to have to do a similar thing. However, if you notice, there's a negative in front of that x squared. So you actually are going to have to factor out that negative before you even start, because you want that first coefficient to be positive. Alright, so let's factor out a negative. So the first one becomes negative. Second one turns into a positive. And the next one becomes negative. Now, as you might already can see, is that what we've come up with here is the same thing that we had in the first one, just without that negative in front. So now it's keeping the negative in front, factor it out again, and I know it's going to be the same, at least for the factors in the middle, and so our solutions are also the same, 2 and negative 4. Now for this next one, now the leading coefficient is not 1, and usually you think, oh, well, I'm not going to do the Xbox method, but before you do that, check to see if maybe that a value, that first one, can be divided into the rest of the factors. And it looks like it can, because it's 2. 2 goes into 4 and 16. So what I can do is pull out the 2, and now I have x squared plus 2x minus 8. Hey, look at that! Same thing again. So now I know that this factors out to x minus 2 and x plus 4. And the solutions are the same for all three of those. Okay? Okay, number 31. Find the zeros for the following functions. Okay? Guess what? You're doing the same thing. Finding the roots, finding the zeros. Same stuff. Okay, so let's see what we can do here. Now this one, what number multiplies to equal 11, but then adds to 6? Well, the only problem is that 11 is a prime number, so that's not going to work. So we're going to have to try something else. Maybe, what if I do completing the square? Okay, so now, instead of just doing straight up factoring, I'm going to set this equal to 0, subtract 11 from both sides, move 11 to the other side, and now it will be negative 11 on the right. And now I'm going to complete the square. And remember, if I add whatever I added when I complete the square, it goes both on the left and the right. Remember, to complete the square, b over 2 squared. And in this case, is going to be 6 over 2 squared, which ends up being 3 squared, which is 9. So now it's going to be x plus, actually let me just write it in there. So now it'll be 9 here and 9 here. And factor out the first one, and I know this will factor out to x plus 3 squared. Okay, and if you want to figure out, if you want to know how that goes to that, do the magic x. Okay, and then add up the other side. Negative 11 plus 9 will be negative 2. And now we're going to use the square root method here. Just take square root of both sides. And I end up with x plus 3 equals plus or minus, and if you notice there's a negative inside the square root, what's that mean? It means imaginary number, so we can take I out. Now let's subtract 3 from both sides, and now we get x equals negative 3 plus or minus I times the square root of 2. Now what I'm going to do is I'm actually going to figure out the decimals for this. Actually, no, I'm not, because this is a imaginary number, so I'm going to leave it as is. So that would be our solution. And if you want to write it out 2 times, you would say there's 2 solutions. Negative 3 plus I times square root of 2, and negative 3 minus I times square root of 2. And I decided not to do round it out and find the decimal because there's an I there, and so that complicates things. Alright, and it doesn't really help us out. Okay, now the next one. Okay, so now this one I'm going to again complete the square because there's no 2 numbers that I can add to positive 4 but then multiply to negative 3, because really my only options are 3 and 1 because 3 is a prime number. But if I make both of them positive, then I can't get a negative 3. And if I make both of them negative, then I can't get, then it'll still be a positive 3. So I'm going to have to use a different technique. So completing the square, let's do that one. So now set this equal to 0, add 3 to both sides. Now I have x squared plus 4x plus the square. And I have positive 3 over here now, plus the square. So now let's figure out, Now let's figure out what that perfect square is going to be. Okay, so remember. Okay. So now 4 divided by 2 squared. Well, that's 2, which is 2 squared, which is going to be 4. So 4 here and there. Okay, let's rewrite our equation. And I know that that will factor out to x plus 2 squared twice, and we have 7 over here. So now we take the square root of each side. Now let's bring our equations over here. So now we end up with x plus 2, and don't forget plus or minus the square root of 7. Now let's subtract 2 from both sides. And we end up with x equals negative 2 plus or minus the square root of 7. Now this is a case where, let's go ahead and get the decimal of that answer. So now we'll get, actually we can do it like this. And let's do the square root of 7. Actually, let's do it like this. We'll do negative 2 plus square root of 7 equals, okay, point. So first solution will be 0.64. Actually, let's round that to the nearest hundred, so it'll actually be 65. And then we'll have, the next one will be negative 2 minus the square root of 7, which is negative 4 points rounded to the 5.65. Okay? Okay, and there's our solutions there. Alright, let's go to this one. Now we're working with complex numbers. So what is the complex conjugate of each of the following numbers? Okay, so let's talk about conjugates for a second. Okay, so if you actually look back at Unit 3, and look, all I have to do is look at my table of contents, and I can find it. It's right there, conjugates. So I'll turn to page, let's see, 52. So I turn to page 52, and there's my conjugates. So conjugates. Alright, well, it has to do with opposites. So, for instance, if I have A plus B, then the conjugate is A minus B. Or in other words, let's try it. Look at this one over here. If I have 2 plus 3i, the conjugate is 2 minus 3i. Okay, so basically the conjugate is simply just the opposite. If you have a binomial or two numbers, two terms, and it's plus or minus, then the conjugate is the same thing with a minus or a plus, or the opposite. Okay? So, going back to this, what's the conjugate of 3 plus I? Well, it's just simply 3 minus I. Conjugate of negative 5 minus I. Simply just negative 5 plus I. And that's it. Okay, and we're going to use those in a minute to solve our equations as well. So now, let's go over here. It says, what value of C makes this equation true? So actually, we're going to have to do a little bit of thinking here. Thinking and multiplying and subtracting. So first, let's evaluate the left side, and then we'll see what we actually have to plug into C. So this takes a little guesswork. So let's rewrite this as 5, and then negative 3 times 2i would be negative 6i. And then negative 3 times negative 4 would be negative positive 12 equal to 17 plus ci. Okay, now let's add up the left side. We get 5 plus 12, which is 17 minus 6i. So now we're pretty close. And as we can see, C has to be negative 6. Pretty easy, right? Alright, so now, simplify that. So we're not going to use the conjugates yet. We're going to actually use that in this problem, but before we get there, let's solve this one here. Now, to solve this, what you're going to do is multiply the top and bottom by I. Why do we do that? Because I know if I do I times I get I squared, which is equal to negative 1. And if you want to remember where that's at, go back to that same Unit 3, and let's see how. Go back to our table of contents, and it looks like multiplying binomials. Well, let's check that out. Actually, you know what? We're dealing with complex numbers, right? So let's go to complex numbers. That's on, for me, page 50. Huh, okay, page 50, this one here. And looks like this one. So I have to do a little research. You know, that's what it takes when you study. Let's look at the conjugate section we were just looking at. Ah, look at that. That looks pretty similar to what we're doing. Yeah? Where we're doing some multiplying times I. Okay, so you'll find that there in the conjugate section. Alright. Now, yeah, so in other words, I multiply times an I get a whole number. And we don't like i's on the bottom of our equations. So that's why we need to get rid of it. It makes life easier when we deal with these things in the future. So simply, 5 times I on the top, and then I get 7i squared, which I know that I squared is equal to negative 1. So then that works out to become negative 1, and I can just make this whole thing negative. Okay? And it's negative 5i over 7. Now, this one over here, we said we were going to use the conjugates. So we're going to do a similar process. We're going to multiply the top and bottom by the denominator. But this time, we're not going to do the denominator itself, or just I. We're going to do 3 minus I, or the conjugate. And so if we do that on the bottom, we have to do it on the top. And the reason I do that, 2 reasons. 1, it's going to get rid of our I. And 2, because when you actually multiply the bottom times the conjugate, it works out really nicely. If you look here, let me pull this up. If you look over here on the front where it says, let's see if I can get this up there, a plus b times a minus b equals a squared minus b squared. That means if you multiply a binomial times its conjugate, then it's equal to the first term squared minus the second term squared. Okay, and you can do it the old school way. You can FOIL this out. You can follow this bottom part out if you want, or you can follow that formula. So, in other words, for the bottom, that's going to be the first term squared, which is 9. So 3 squared is 9, minus the second term squared, which is I squared. Alright, now let's do the top. I'm going to FOIL out the right part first, so that'll be 21. Let's see, then it'll be negative 7i minus 6i, so that'd be minus 13i, and then negative 2i times negative I, which would just be positive 2i squared. Okay, so now let's work that out again. Now I've got to distribute this 20. So now we're going to get 20 times 21. Bring up a calculator real quick. Actually, let's do this. And then bring it up like that. So now, times 21 equals 420. Okay, so we get 420 here. Then we have 20 times 13. This is 260, and that was negative, so now it's 260i. Now we have 2 times 20, which would be 40. Okay, now we get all that over, now this is I squared, right? So this actually can work out to be this. It's negative 1. Alright, and then let's keep simplifying here. Now this 40i squared, that's going to be negative 1. So then that will become 40 minus 260i minus 40 now, because that was a negative. And then the bottom over here, 2 negatives become positive, so that becomes 10. And now we're going to do combine like terms on the top. 420 minus 40. Well, that will be 380 minus 260. Oops, sorry. Minus 260i. And we're almost there. Now remember with a complex number, we have to split it up, because we have to have 2 parts. So now let's split that. 380 over 10 minus 260 over 10. And divide both of those by 10. Simplifies out to 38 here. And 26 here. I. And there's our answer, by the way. Alright? Okay. Now let's go on down here. Again, what's the conjugate of this number here? 9 plus 7i. Well, it's just the same thing with a negative in the middle. 9 minus 7i. Then we go back over here. We can do a little bit more multiplying. Well, this is going to be equal to 2 of these, so that's squared. So simply just have to rewrite it, expand it out. Let's write that correctly. Oops, not with the 2. And write one more time. And FOIL it out. Okay, so the first term will be 9, positive 9. And then we'll do this the long way, just so you guys can see it. Oops, sorry, it should be 21. Just 21i minus 21i. Okay, and then plus 49i squared. Okay, let's combine terms. 9 here, then we have negative 21 and negative 21, which become negative 42i. And then the last number will become negative because of the I squared, which is also negative 1. And then we're going to combine the 9 and negative and 49. So that means 9 minus 49 would be 40, negative 40, minus 42i. And remember, your real number has to go in the front first. So that's why I put the negative 40 on the left and the negative 42i on the right. Okay. Now, polynomials. Okay, so with polynomials, it looks like we're going to do the box method, or we're going to do division. And so what I'm going to do is on one of these I'll do the box method, and the other I'll do synthetic. Okay, so we're dividing this polynomial by this binomial here. Let's pick a new color. And I think I'm going to do the box method first. So let's do the box method with this one. So we draw a box, and remember you leave it open on one side. And the first thing I want to put is this binomial here that goes on the side, and then I draw the first number here, and then you guys know I like to do some highlighting, and I highlight the second term, pick a new color, let's do blue, and then highlight the next term, and the last one I'll do is pink, and highlight the last term. Okay, and one thing I didn't mention is that make sure that you're not missing any terms. Make sure you have all exponents present. And here I've got 3, 2, there's a 1 there, we can't see it, and then obviously 0 here. Okay, if you got any missing, make sure you include those terms. Okay, now let's go back to our red color. Now the first step here is to say, what do I have to multiply times this x on the outside times to get x to the 3? Well, that'd be x squared. Then you go down to the bottom column and you multiply across, so 5 times x squared is 5x squared. Now you use this term and this term up here, which are highlighted yellow. You say, how do I get from 5x squared to 4x squared? Well, I'd have to subtract x squared, or 1x squared if that helps. Okay. Now what do I multiply times x to get negative 1x squared? It would have to be negative x. And then go down again to the bottom. What do I have to multiply, or just multiply it, negative x times 5. And then again, what do I have to add to negative 5x to get to be at negative 8x? Well, I have to subtract 3x. And then what do I multiply times x to get negative 3x? Well, it would be 3. And remember, when you get a constant at the top, that means, or a number with no variable, I write remainder, because my last number will be my remainder. And then multiply down here, so that's negative 15. And then what do I have to add to negative 15 to get to negative 9? Well, I'd have to add 6. Okay, so now I get my polynomial answer from here, x squared minus x minus 3, and then the remainder 6 over what I divided by, which was x minus 5, that up there. Okay, and there's my answer. Okay, now let's do this one. So which of the following is not a factor? Well, I'm going to have to use synthetic division, or the box method, and figure out which of these does not have a remainder. I mean, has a remainder, because the one that has a remainder does not go into it evenly. So for instance, if I asked you that same question over here, does the x plus 5, is that a factor of this one? You'd say no, because there's actually a remainder. If the remainder was 0, you'd say, oh yeah, for sure, that is a factor. So now, which is not a factor, so let's do synthetic division. Okay. Okay, so make sure again there's no missing terms. And like I've got 3, 2, 1, 0, so it looks like we're good. So now let's first test this one. And if you remember with this, I'm actually going to do the opposite of the plus 2. Okay, so you don't plug in plus 2, you're going to actually put negative 3, because remember x is a liar when we do synthetic division. Okay, so now write the coefficients, 6, 13, 1, negative 2. Bring down the 6. Then it's negative 2 times 6, which is negative 12. 13 minus 12 is 1. Then negative 2 times 1 is negative 2. Then 1 minus 2 is negative 1. Then negative 2 times negative 1 is positive 2. And negative 2 plus 2 is 0. So guess what? It is a factor because our remainder happens to be 0. So that's all we really need to do, is that we know that one's a factor. So by process of elimination, that one must not be a factor because it's got to be one of them, right? So that would be it. Now just to double check, let's go through it real quick. So this would be 4 because this is negative up here. And we'll do this real fast. So let's bring down our 6. 6 times 4 is 24. Then 13 plus 27 is 37. Then 37. Make sure I did that right. Okay, 37 times 4, that'd be, let's see, 120 plus 28. So that'd be 148. And you guys can already see where this is going. We got some big numbers, so probably not going to end up even. So now that'd be 149. And let's see, 4 times that is about almost 600, so that's 596. 596. And then that plus the negative 2 plus that would be 594. So that's obviously not a factor. It's huge, right? It's a big remainder. Okay, so now let's say I asked you for the equation using synthetic division. Well, the equation here on the left would be 6x squared, because remember the first term is actually that first term over there, one less than it, minus x minus 1, and then plus 0 over what we divided by, which was 2, x plus 2. But that doesn't matter because it's only 0, so that would be it. Okay, let's move on to one down here. Use synthetic division method to evaluate this function, okay, for this value. So now we're going to use synthetic division again. Make sure there's no missing terms. And actually, what we need to do, if you notice, there's x to the 5th here, so we actually need to rearrange it, because it has to be in standard form, which is from highest degree to lowest. So put negative 3x to the 5th. And I'm missing the x to the 4th term, so I need to include 1 there. And I'll make it 0x to the 4th. And my next one would be 5x cubed, and then plus 2x squared, and then plus 7x minus 10. Now we're ready. So now, take that negative 2, put it there, and this is only when we're evaluating, okay? So eventually, whatever our last answer is over here, what typically our remainder when we divide, that's going to be our answer. So now, write the coefficients, 3, 0, 5, 2, 7, and negative 10. Okay, bring down this negative 3. Okay, negative 3 times negative 2 is 6. 0 plus 6 is 6. Negative 2 times 6 is negative 12. 5 minus 12 is going to be negative 7. Negative 7 times 2 is going to be positive 14. 2 plus 14 is 16. Negative 2 times 16 is negative 32. And then negative 32, 7 minus minus 32 is going to be minus 25. Negative 2 minus 25 is going to be 50. And then negative 10 plus 50 would end up being 40. So there's my answer. So now h of negative 2 is equal to 40. So remember that last number is going to be your answer. Okay. Hey, what is a factor of x to the 3rd plus 9x squared plus 10x squared minus 24. So this is just like the one we did a minute ago. So this time I'm going to use the box method. Alright, and I'm not going to use Euler's this time because I'm going to go a little quicker. So now let's choose the first one. Okay, so we'll put x plus 3 here, and then take our first term. And it looks like we're okay. We have all our terms, so I don't need to include any missing ones. Then the number up here is going to be x squared, because x times x squared is x to the third. Then 3x squared here, multiply it. Then what plus 3x squared equals 9x squared? Well, that's going to be 6x squared. And then 6 times 6x equals 6x squared. Then 6x times 3. Then what what plus 18x equals 10x? Well, that'd be minus 8x. So then 8 times x is equal to 8x, negative 8x. And we know that the next one's going to be our remainder, because that's a constant. And then negative 8 times 3 is negative 24. And then negative 24, what do I have to do to get from negative 24 to negative 24? Well, I just add 0. And so that means our remainder is 0. So that means this is a factor. So x plus 3 is a factor. And by process of elimination, I know that that one's not going to be it, because it's one or the other. Okay? Alright. That concludes part 3, and you can watch part 4 in the next video.